Today we will talk about rules of exponents. The first rule of exponents is the product rule. With this rule, we'll keep the base and add the exponents. We have the quotient rule. With the quotient rule, we will keep the base and subtract the exponents. Our power rule is when a power is raised to another power. We will keep the base and multiply the exponents. The zero exponent rule, a base is raised to the zero power is equal to 1. And then we have the negative exponent rule. With this rule, we will invert or flip the expression to make the exponent positive. In the first example, we have x raised to the negative third power. We will create a fraction by putting the expression over 1. Once we have the fraction, we'll flip or invert the fraction, which causes the exponent to become positive. Let's look at an example. In this example, we have x to the third times x to the fifth times x. We're multiplying the same bases together. Remember, when a base does not have an exponent, the exponent is understood to be 1. So in multiplying these bases together, we will keep the base and add the exponents. 3 plus 5 is 8. 8 plus 1 is 9. So when multiplying the bases together, we now have x to the 9th power. Our next example is using the quotient rule. We have y to the 8th divided by y to the 2nd. In this rule, we will keep the base and subtract the exponents. So we will subtract 8 minus 2. This gives us an expression of y to the 6th power. Next is our Our next example is the power rule. Our next example is the power rule. Remember, with the power rule, we have a power raised to another power. We will keep the base and multiply the exponents. So we have 3 times 5, so our new exponent is 15. Next is our zero exponent rule. The zero exponent rule says that any base raised to the zero power is equal to 1. Here, the first example, I have a to the 0 power. A to the 0 power is equal to 1. In the second example, I have 7a to the 0 power. This is 7 times a to the 0 power. The only base with a power of 0 is the a. 7 is still 7, but a to the 0 is now 1. So we simplify to just 7. Lastly, I have 7a in parentheses to the 0 power. Here, the 0 is up against the parentheses. So this means that everything in parentheses receives the 0 power. So 7a in parentheses to the 0 power is all equal to 1. Here's an example of using more than one rule to simplify the expression. In this expression, at the beginning, we have the numbers 2 at the numerator and 4 in our denominator. So we pretend like the 2 over 4 is just a normal fraction. We reduce the fraction and it becomes 1 over 2. Then I have x to the 5th over x. Again, we're going to use the rule. We have a same base in our numerator and denominator. So we're going to subtract the exponents. This gives us x to the 5th minus 1. Y, we have y to the 9th over y to the 7th, so we have y to the 9 minus 7. In our numerator, I have the 1, x to the 5 minus 1 is 4, 9 minus 7 is 2 for the exponent of y. I have a denominator of 2. My final answer, I can leave off the 1. I have x to the 4th, y to the 2nd, all over 2. Here is an example of using the negative exponent rule. We have a negative 3, a negative third power, on the outside of our parentheses. So here, we will give every factor inside the parentheses a power of negative 3, including our denominator. So because we have exponents of negative 3, to make the exponents positive, we will have to invert the values. The first number that we will want to invert is the 3 to the negative third power, and I'll show you why. I have m squared to the negative third over, I'm going to put the 3 now to the positive third power and multiply by b to the negative third. So on my numerator, I have m to the negative 6th over 3 to the third power is 27, and I have b to the negative third. Now, when I invert the m to the 6th will come to the bottom, the b to the third will go to the top. So I'm really just switching places with the m and the b and their exponents. So my final answer is b to the third over 27m to the 6th.